This topic, sadly, is the last one for this semester. Let's go ahead and get started. And what we're going to talk about until the end of the semester is the intermolecular forces and energy. And states of matter. So we'll talk about solids, liquids, and gases. So not too bad. But today, and again, there's your vocabulary. Today it's a really short topic. It's actually over density. Okay. And you've already done the density lab. So the first thing I want to talk about is derived units. And again, when we talk about derived units, we have quite a few derived units in science, and some of you may already use derived units, you just don't realize it. In other words, if Terre Haute is about 65 miles from here, and it takes me 1 hour to get there, what is my rate of speed? 65 miles per hour. That's a derived unit. Okay, so in other words, we're taking two units and we're putting them together. Back when we did we use, I'm trying to remember the constant, Planck's constant when we were working with light? Yep. The joule seconds, that's also a derived unit. So you don't have to divide the units, they can be multiplied as well. All right, density. Hopefully everybody remembers what density is talking about, but again, it's defined as the mass per unit of volume. So it's a ratio of the mass to volume, which is nothing new there. Calculating density, again, the equation that we'll use is density is equal to the mass over the volume. And a student showed me this about 8 or 9 years ago. I kind of like this. It's called the density triangle. And it integrates the equation density is equal to mass over volume. So if you want to go and do an equation, here's how we do it. And whenever you move this way, you're multiplying. Whenever you move this way, you're dividing. So if I want to know what the equation to solve for density is, it's mass divided by volume. If I want to find out what the equation is for mass, I do density times volume. If I want to find what volume is, then I do mass divided by density. Now again, we always show our units, but the units will also verify that we have the calculation set up correctly. So the types of calculations that we're going to work with today, sometimes I'll ask you to calculate the density, sometimes I'll give you the density and the volume and ask you to find the mass, and other times I may give you the density and mass and ask you to find the volume. In other words, you always know 2 of the 3 variables. Just solve for the unknown. Okay. And that's it for that. Okay, so let's take a look at, there's 2 practice problems. There's 2 practice problems that I want to go over here, and then the rest is your homework. So there's 2 practice, and then there's 6. Six really good ones. All right. So number 1, it says calculate the volume of a piece of a certain metal that has a density of 4.33 grams per centimeter cubed and a mass of 75.2 grams. Now, don't forget that when we do these, the units for this. Actually, let's do it larger here. Okay. So again, it's grams per unit of volume. Now, I think in the lab we didn't use centimeters cubed. What did we use? What did we use for our volume?
I don't know, that was like 3 weeks ago.
It was a while ago. What was it? Milliliters, good. So if you have milliliters, that's a volume unit. How come we don't cube that? It's already a volume. Very good. And it's nice to know that if you have 1 milliliter, that's equal to 1 centimeter cubed. That's a nice conversion to have in the back of your mind. You may also hear on TV or over here a doctor say, hey, give them 20 cc's. What's a cc? Cubic centimeter. Okay, so we don't ever use cc's in here, but that's also the same thing. We don't use cc's, and I don't know if they do it in Project Lead the Way or not. Okay, so a cc is a cubic centimeter. All right, so all of these are equal to each other. So there's your volume. So we could go grams per milliliters or grams per centimeters cubed. I've also seen it as kilograms per liter. All right, so it can be a lot of different things. Also, the mass, some form of mass, and again, So again, we're going to let our units help us make sure that everything's working out here. Or it could be centimeters cubed. Okay. Alright, so let's look at the first problem. So we always want to know what we have, and it says calculate the volume. So we're actually looking for the volume. Okay. So does anybody remember the equation for volume for that? Mass over density? So again, we're going to verify, or at least I'll do it here, that we're actually getting a unit for volume, because we just don't want to throw numbers in there and hope it's right. So what's the unit for mass again? Grams. And what's the unit for density? Grams per milliliter. Okay. Or centimeter cubed, which I think is, in this case, whoop. So let's go centimeters cubed. Okay. Now, what is our final unit there?
Centimeters cubed.
Centimeters cubed. Again, if you talk about the inverse of the inverse, in other words, if I do the inverse of 1 over x, what does that equal? X. All right. I think we may have talked about that earlier. So really the grams cancel out, and that's another reason why I'm not a big fan of having two division signs. The way that I would really write this would be this, and I'll put centimeters on the opposite side of the grams. Okay, so the grams cancel out, you're left with your unit that you're looking for. Okay, so that's just a nice little refresher from what we talked about earlier in the year. So we do have this equation here where it's volume is equal to mass over density. The mass in this problem is what? 75.3. There you go. And the density in this case? 4.33 grams, and I'll put the centimeters cubed here again. Grams cancel out. What unit do we have? Centimeters cubed. And then make sure your calculator. Yeah.
Where's your cool calculator?
They're all cool.
No, the other cool one.
So 17.4 centimeters cubed. Okay. Let's look at the second one. Ooh, look at that. Percent error. What's the equation for percent error? You guys did it on your lab.
6%. The true value minus the lab value.
Good, okay. So true value minus lab value. Or if you did lab minus true, tomato, tomato, because again, we have our absolute value. Now some of you had negative percent error. You didn't listen to that. So make sure that you actually drop the negative. And what are we dividing it by? True. Very good.
True.
And then of course multiply it by 100 to get your percent. Okay. So that'll always be provided for you. And I would write this at the top of your paper since I don't see it on here. So right up here somewhere for you. Okay. So number 2 says calculate the percent error for a measurement taken in the lab for the melting point of a certain pure substance. If the temperature was taken at 155.3 and the literature value, which is the true value, is 169.8. Okay. So I'm going to erase that. So our percent error, we have, what is it again? Temperature was taken at 155 minus 169, and it's divided by 169 times 100. So anybody get an answer? Good. Okay. Now if you left a negative in your calculation, drop drop it because it's dropped here. All right, so the other problems are doing some percent error and using this equation here. Okay? I like it. Giddy up.